Nomenclature and naming ionic compounds. Common names are arbitrary and often related to the physical or chemical properties of the compound. Systematic names precisely identify the chemical composition of the compound. So here are some examples. So N2O is laughing gas as the common name, but its systematic name is dinitrogen monoxide. HCl, common name muriatic acid, systematic name is hydrochloric acid. CaCO3 is limestone as a common name, but its systematic name is calcium carbonate. And NaCl is table salt, but its systematic name is sodium chloride. In this course, you'll be learning how to assign systematic names, and you will be responsible for learning how to name molecules and compounds based on their systematic name. So some definitions to start off with. Mono means one. So monoatomic ions contain one element. For example, sodium. Binary ionic compounds contain two elements. For example, sodium and chloride, or chlorine, which creates sodium chloride. Polyatomic ions contain more than two elements. So here you can see NH4OH is ammonium hydroxide. When we want to name monoatomic cations, now cations are going to have a positive charge when they are in their ionic state. Most of the metals, or all the metals on the periodic table of elements, have the ability to form cations. So they're going to be positively charged in their ionic state. So some examples here are K, which is potassium, becomes K+, the potassium ion. Mg, which is magnesium, becomes Mg2+, the magnesium ion. Al, aluminum, becomes Al3+, the aluminum ion. So when we see it in its ionic form, it has the same name as in its regular elemental form. But with anions, so anions are going to end up having a negative charge, and these are going to be nonmetals. So when we form an ionic compound is formed between a metal and a nonmetal. The metal part, you're just going to keep the same elemental name, but the nonmetal part, the anion, the part that's going to become the negatively charged particle, you're going to use the root of the word and then add an IDE ending. So if we look at this first one, hydride, this is hydrogen. So we we use just the stem, we drop the last part of it, and it just becomes IDE. We add that IDE ending at the end. N is for nitrogen. So we drop the ending, we keep the nitr, and then put IDE ending. P is for phosphorus. So we're going to drop the ending, keep phosp, and add the IDE ending. O, oxide. S for sulfur becomes sulfide. Se for selenium becomes selenide. F for fluorine becomes fluoride. Cl for chlorine becomes chloride. Br for bromine becomes bromide. And I for iodine becomes iodide. So now we're going to go into how to name binary ionic compounds. So again, binary ionic compounds contain... So naming binary ionic compounds. Binary ionic compounds contain only two elements, a metal and a nonmetal. Compounds containing a metal that forms only one type of cation. So what do I mean by that? When we look at this periodic table here, we can see the metals and the nonmetals. And when I discussed how we figure out charges, I said everyone in group 1A is going to have a +1 charge. Everyone in group 2A has a +2 charge. Then we go over to group 3A, we have Al3+, And then we're at the anions. So we have group 5A. These are going to have a 3- charge or a -3 charge. Group 6A, -2 charge. Group 7A, -1 charge. And then there's no charge on these noble gases. But there are elements in the periodic table in the transition metals area that can form ions with multiple types. So what we're talking about first is we're going to talk about compounds containing a metal that forms only one type of cation. So we're talking about these main group elements where we know that they form only one type of cation. So you're going to write the name of the cation. So for this first one, if we look up Al on the periodic table of elements, we know that Al is for aluminum. So we're going to write that cation, aluminum. Then we're going to write the name of the anion with the IDE ending. So this F is for fluorine, but we're going to put the IDE ending, so this is fluoride. So aluminum fluoride. And I know I wrote those close together, but those are two separate words. For the next example, Ca is for calcium, calcium. And the N is for nitrogen, but we're going to use the IDE ending, nitride. K is for potassium. Cl is for chlorine, but we're going to put the IDE ending because we're talking about it in its ionic form, chloride. So that would be the systematic names of these guys. So if we continue on these examples, I'd like you to pause the video, try to name these, and then in a little bit we'll unpause and I'll go through the answers. Okay, so the first one is barium iodide. Lithium oxide. Calcium carbide. Silver sulfide. And rubidium nitride. So there's a chart that you can use when naming binary compounds. So for binary compounds, if there are two nonmetals, you're going to use prefixes. So we haven't talked about naming covalent compounds yet, or molecular compounds. If it's a metal or nonmetal, we're going to be naming, these are ionic compounds. If they only have one type of cation, we're going to name the metal, and then we're going to use the stem of the name with the IDE ending, just like we've been doing in the last few examples. But if we do have a metal with varying types of cations, you have to determine the charge of the cation, and then you can choose the appropriate OUS or IC ending on the metal, and then the stem name of the nonmetal. So use Roman numeral after the cation name, stem of the name of the nonmetal IDE. So we're going to go through this part in just a little bit. Naming acids and bases. Will be covered once we actually go through acids and bases. So not in this lecture. So what is the correct name for CDF2? cadmium fluoride. Why is it this one and not this one? You got to look at the spelling. So it's UO instead of OU. So compounds containing a metal that can form two or more types of cations. So in the stock system, the name of the cation is the name of the element with a Roman numeral in parentheses equal to the charge. So Fe2 plus is iron 2, Fe3 plus is iron 3, Sn2 plus is tin 2, Sn4 plus is tin 4, and so forth. So again, here's a reminder of these ones that can contain more than one stable ion. So this is a good reference chart to just review on your chemistry aid sheet. You can also just highlight these and make a note that these are able to form more than one stable ion. So if we want to name binary ionic compounds with ions, cations that can form more than one stable, have more than one stable charge, we're going to write the name of the cation, write the charge on the cation as a Roman numeral in parentheses, and then write the name of the anion with the suffix IDE. So cobalt. Cobalt is one of those that was identified as having two different forms. So we have to figure out what form we're dealing with. So cobalt, and we have Cl3. Now to figure out the charge on cobalt, we actually have to take what's down here and flip it up, and take what's down here and flip it up. So this becomes CO3 plus and Cl minus. Now where did the pluses and minuses come from? Remember, the metal is always going to have a plus charge, and the nonmetal is going to have the negative charge or minus charge. Where did the 3 come from? The 3 came from this chlorine. We flip it up. Where did the -1 come from? Well, cobalt, it's assumed that there's 1 here because otherwise we wouldn't write cobalt. So there's at least one of them. We flip up that 1, and that's how we get the charge. So now we look at this and see if it makes sense. When we flipped up the charges, does chlorine in its ionic form, so does chloride, actually have a -1 charge? Let's go here. We see chloride, it's -1. So that's the true charge of chloride. So this would be the true charge of cobalt. So to name this one, it would be cobalt 3 chloride. So we can't just name it the other way because we don't know what form of cobalt we're dealing with. Are we dealing with cobalt 2 plus or cobalt 3 plus? In order to determine which one we're dealing with, we need to flip up the charges. So the 3 gets flipped up to the cobalt and the 1 gets flipped up to the chlorine. Now chlorine in its ionic form is called chloride, so with the IDE ending. And we indicated what form of cobalt it is by putting the Roman numerals in parentheses. Roman numerals and prefixes that you'll need for this are on the first page of the chemistry aid sheet. So let's look at the second one. So iron has 2 forms. We need to know whether we're dealing with the 2 plus form or the 3 plus form. So what we're going to do here is flip up our charges. So the 2 goes to the iron, the 3 goes to the phosphorus. So this becomes Fe 2 plus P 3 minus. Now we have to confirm that phosphorus actually has a -3 charge. Looking at phosphorus on the periodic table, it's not listed on this one. Let's go back up here. Phosphorus, here it is. 3 minus. So that is the true charge of the phosphorus. So this is the true charge of the iron in this molecular formula. So we have iron, and we know what type of iron because it's the 2 plus, so this is iron 2 phosphide. So it's phosphorus with the IDE ending. Okay, next one is copper. So copper, multiple forms. So we got to figure out what form we're dealing with. So we're going to flip up the charges. We're going to flip this one and flip this one. And that becomes Cu plus and O minus. Now we're going to confirm that this is the true charge of oxygen. So let's go back here. Oxygen. Oxygen actually has a 2 minus charge. So because oxygen actually has a charge of -2, we know that there must also be an error with our copper. So copper has to be increased by the same amount that our oxygen was. So we went to 2 minus, so we do Cu 2 plus. Later on, we will go through how to take them from name to formula, and we flip down the charges. And when you flip down charges, you always reduce it to the lowest number combination. So you'll see how we go in the opposite direction, and that'll make this make more sense as we go through this lecture. But for now, you always want to confirm the charge of the anion. If the charge is inaccurate, you need to increase it to what it's supposed to be, and then increase the cation by the same amount. So now we know that this form is actually copper 2, and we have oxygen, so oxide. And here is another example. We're going to flip up the 4 and flip up the 1, so this becomes SN, tin, 4 plus, and BR, minus. We always need to confirm the charge of our anion. Bromine does have a -1 charge, so this must be the true charge of our tin. So this becomes tin 4 bromide. Okay, so go ahead and pause the video. Now remember, these are a mixture of elements that have more than one possible cation and elements that just have one possible cation. So you're going to want to use Roman numerals for anything that has more than one cation possibility in its stable form. So go ahead and pause, and then we'll unpause and go through the answers. Okay, here we go. Cobalt. I know that cobalt has more than one form, so we're going to flip up the charges. This becomes CO3 plus and Cl minus. I need to confirm that chlorine in its ionic form, chloride, has a -1 charge, and it does. So this is just cobalt 3 chloride. So potassium only has one possible ionic form that's stable, so this is just potassium sulfide. Mercury. Mercury has a couple different forms. So we're going to flip up our charges. This becomes mercury 2 plus and fluoride minus. If we look at fluoride on the periodic table of elements, we know that that is the true charge, so this must be the true charge of mercury. So this becomes mercury 2 fluoride. Silver only has one form, so this is just silver bromide. Now with these ones, we're going to flip them up. This becomes Fe2+, P3-. We want to confirm that phosphorus does have a -3 charge, and it does. So this charge is correct. This one must also be correct. This becomes iron 2 phosphide. And this last one. So lead has different forms. We're going to flip up our charges. This becomes Pb4+, I-. Iodine is actually a -1 charge. So because this is correct, this must be correct. And we have lead 4 iodide. Okay, so go ahead and pause, try to figure this one out. All right, this is mercury 2 sulfide. Why? So when we flip up our charges, we have Hg plus and S minus. But when we go to the periodic table and look at our table of charges, we can see that S is actually supposed to be 2-. So because we increased this one, we're also going to have to increase this one to get to our actual charge. So this becomes Hg 2+. This is why we always check our anion when we do our flipping. So mercury 2 sulfide. Polyatomic ions. So we talked about how to name monoatomic ions, binary ionic compounds. Now we're going to learn about how to name the polyatomic ions and compounds containing polyatomic ions. So poly means many. Polyatomic ions is an ion that contains 2 or more elements. The important ones here are indicated by the arrow. Those are extremely important, especially if you're in the health field. Ammonium carbonate, chlorate, hydroxide, cyanide, nitrite, phosphate, sulfate. So those are really important medically. And those will be discussed in future classes as well. So make a note of those, especially if you haven't completed microbiology or A&P yet. Those are really important. So many polyatomics that contain oxygen are called oxyanions and generally have the suffix -ate or -ite. So this one, sulfate, this one's nitrate. The ions whose names end in -ite have one less oxygen. So sulfite versus sulfate. If you see O4, it's sulfate. O3 is sulfite. If you see O2, it's nitrite. O3 is nitrate. Some polyatomic names end in IDE, so hydroxide, cyanide, sulfide, or hydrogen sulfide, peroxide. And then there's only one polyatomic ion that's positive, and that's ammonium. Ammonium is different from ammonia. Ammonia is NH3. Ammonium is the polyatomic ion NH4+. So naming compounds containing polyatomic ions, write the name of the cation and then write the name of the anion. So on the second to last page of the chemistry aid sheet, you'll see some cations and anions, including some polyatomic ions. So you can see the charges listed and Some of these have multiple charges. You can see like the tin 2 and tin 4 is listed here, the iron 2, iron 3, and so forth. But then you'll see those polyatomic ions listed there. So we're going to use that to try to name these compounds. All right. First, anytime we approach something like this, we're going to look here at the polyatomic ion and try to see if it has two or more elements, then we know that it's a polyatomic ion. So Cl and O we know is probably one of the polyatomic ions. ClO2 is either, so ClO is either going to be chlorite or chlorate. In order to figure out what form, we have to flip up our charges. So we're going to flip this up, Hg becomes 2+, and ClO2 becomes minus. So ClO2 does in fact have a -1 charge based on our polyatomic ions, and now we know that it's chlorite. So because this is the true charge, we know this is the true charge, and we can call this mercury 2 chlorite. Now we're putting ITE because that's the actual name of the polyatomic ion. We're not using an IDE ending, and we're not putting chlorate because if you look at that table that's provided in your chemistry aid sheet, again, second to last page, right before the periodic table, you're going to see the name chlorite and ClO2 minus. All right, moving on here. This is zinc phosphate. There's only one form of zinc. Phosphate is one of our polyatomic ions. So we know that it contains a polyatomic ion because we see 3 different elements here. A lot of times, polyatomic ions will also exist in parentheses, but not all the time. So here we go. We have a bunch of different atoms here, elements. So we're going to try to break this down and look at our table of cations and anions. First of all, we can chunk this into 2 separate pieces. NH4 is ammonium, and NO3 is nitrate. So we are just giving it the name that we see in that table. Here we go. We're going to flip up our charges because lead has multiple forms. So this becomes Pb 2+ and C2H3O2 minus. Now, does acetate actually have a -1 charge? Yep, that's correct. So this must be the true charge of the lead. So now we have lead 2 acetate. How did I know that this is acetate? That table of anions. So be familiar with that table. I would take some time reviewing it. You don't have to have the whole thing memorized, but definitely take a look at it because when you're taking a test and you're having to name these, figuring out the systematic name, if you already kind of have these in the back of your mind, it'll be a lot easier, a lot quicker, and you'll be able to access the resources you need a lot faster. All right, so go ahead and try to figure out this one. All right, the answer is iron 2 sulfate. Why? So we are going to put our parentheses around the sulfate and flip up our charges. This becomes Fe plus and SO4 minus. Now, why didn't we flip up the 4 to the iron? Because this is part of a family, and you're not going to break up that family. Polyatomic ions stay together, and they don't get separated. They're bonded by covalent bonds. So they are together in that marriage type relationship, and you don't separate them. The 4 is part of sulfate, so you never want to take the 4 away from the sulfate family. Now, why isn't it iron 1 sulfate? Well, if you look up the charge on sulfate, it's actually supposed to be -2 or 2 minus. So because, sorry about that, it's 2 minus. So because this one increased, we have to increase this one by the same amount. So this becomes iron 2. Iron 2 sulfate.